So we're just going to cover SQL integrated storage. As I mentioned before, I consider myself an infrastructure DBA. Before I came to Tintri, I've been in Tintri about a year. I was a SQL Server consultant. So I basically went to different sites every other week or so and worked on their databases and worked on their storage and tend to solve their problems. So I solve a lot of problems from a database perspective. So all the things I'm going to talk about is a storage person's perspective of the database systems. And we'll go through that kind of stuff. So let's go get out of PowerPoint and get my view and zoom off of here and into here. So SQL integrated storage. So basically what we're going to talk about basically is what it is, how it really works, a very simple version of it. I can talk on this as long as we really want to. Of course, they've only allotted me 30 minutes. So it's very easy for me to go way over time, especially there's a lot of questions. So feel free to ask the questions. I may have to postpone the answers till later. So we're going to talk about basically, again, how it works, basically show you about per database granularity. So all the things you saw what Rob was showing you per virtual machine, we can substitute per VM and now use the term per database. And I can drill down individual databases. That question about vvols earlier and how I can do this. One of the things I used to do before I came to Tintri, I was actually a big fan of vvols because it allowed me to do database isolation. I could create vvol for just one database and have control over the processes. The problem is, of course, you would have to hire professional services from the storage vendor to come and configure it, and then hire some DBA professional services to come in. So you got 4 or 5 weeks of professional services to configure your environment that I can show people in a demo in 30 minutes, they figure out themselves. Think about the cost of having someone on site for 5 weeks versus a 30-minute demo. I mean, that right there is a good 25-30% of your array costs. Just as one of the cool things about that. And then we're going to talk about performance, the data protection. So the cool thing is we do a lot of massive things with data protection that DBAs have thought they have tried in the past with other storage processes and they never work properly. They all work here fantastic. In fact, how I came to work for Tintri was, Rob Gerard and I go back 5-6 years kind of stuff as friends. And he was telling me all these great things. And I'm like, yeah, that's just marketing vaporware. And then he eventually sat me in front of the system and made it click. And then I started playing with it, and then I started digging into it. And then it's like, what do you mean? I can try this then. It's like, uh-huh. So I started doing, this actually works. And I got really, really excited, which also I tend to talk really fast when I get excited. And the more geeky I get, the more excited I get. So I'll do my best to calm down and talk slower. All right. So TGC, Rob's already showed you this kind of stuff. We have the all managed objects. So I click on the all managed objects, that you see here I have object type. I have virtual machines and databases all mixed in together in the same process. Database versus virtual machine. We can look at a holistic view of everything together in one big picture. Or, of course, we've added the databases tab, which allows us to break things out to just my databases. So only my databases are in here. So we're going to walk this backwards kind of stuff. So how this actually works, just like with the VM store and how we work with that, we create an NFS share or NFS mount point and present it as a data store to VMware or your hypervisor. So then we put the VMs on there. With Hyper-V, of course, they use an SMB share. This is the same technology we use basically from a Hyper-V standpoint of we create an SMB share and we move the database from the local D drive or wherever onto the SMB share, which of course SQL Server has been supported since 2012. It's actually worked before that. It just, SMB protocol was not really functional in Windows 2008. But SQL Server officially since 2012 has supported it. And if you go to Azure or AWS and go under the covers and learn how Azure DB or Amazon RDS kind of stuff works, they're all using SMB under the covers to do all the stuff they do as well. So this is a tried and true technology, and it's not something new and crazy. It's just most DBAs and storage people haven't used SMB to support SQL Server databases. So, and we use Active Directory for control of my security. So basically I create the different shares. You can break as many as you want or as few as you want. Here I just have a dev, basically a prod and dev, and I use Active Directory groups to control my security to it so I can lock things out. Pretty simple concept on that, how we work on the process. Then SQL servers, basically I just add my SQL servers to the system. Adding SQL servers is quite simple. I just need, a host name, preferably the FQDN. We're using right now SQL authentication only. You basically need some credentials so it can connect to it and then not talk to it. Just like you'd be, with VMware adding a new data store, you have to provide access permissions.
Shawn, these SQL servers, can they be physical or virtual, some mix of both?
It's a mix of both. In fact, well, this is a physical, but it's broken, which is why the red little X is here. But the red, connection. This is green. This is a physical box. So we support physical. We support virtual. The only thing we don't support right now is Linux from a SQL Server perspective, and we're talking about that in the future. So now on the databases tab. So now I have all my databases here, and I can now see all my databases across my entire environment in one place. The cool thing now is I'm managing them per database, meaning each system is doing things individually. I can go play with them and figure out what's going on. Like you can see this one's being overloaded my system right now. It's my SQL Bits clone. It's it's not a very big database, so it's only 71 gigabytes. But the cool thing is I can drill down into each of these databases and look at the settings for it. And actually are the settings, the metrics, and see how the performance of this database has been using for the past little bit. You can see it's ramping up right now because before this demo, guess what? I put extra stress on the system so I can show how things are actually working. So if I go to a 1 month view, for example, you're not going to see as much data in here because you see only a little spike because it hasn't been used very much. So let's go back to the 1 hour view, and I can pull up, all the metrics I want to per database. Now think about that. When DBAs have problems, they open up tickets to the storage people. Hey, my system is slow because the ticket came to the DBA of application XYZ is slow. The DBA looks at it and goes, hey, I think the storage is slow, and then opens a ticket to the storage team. And now the hard part, of course, is the ticket may come in, hey, AdventureWorks database is slow. To the storage admin, that means absolutely nothing because you have no idea where it's at. Well, guess what? We now can translate the database name right to where it's at on the storage and look at it. And look at the metrics per database, as deep as I want to kind of stuff, and see where my latencies are coming from, see different things. Let's go back a step here.
What about if a customer want to or need to implement a clustered database? Can you map, share to different SQL Server? Which kind of high availability solution do you support?
Sure. So there's two main types with SQL Server clusters. They call FCI, which is failover cluster instances, which is the traditional SQL Server cluster, which is a shared disk method. Those we currently do not support. The newer method, which you see a lot more of now in the public purview, you see less and less FCIs, and you're seeing a lot more availability groups. And so in fact, you go to most client sites, you would see, probably a 20-to-1 ratio of availability groups to FCIs. And we support availability groups fully. And so we can do all the data protection processes. In fact, we can do our snapshot and cloning processes from the availability group secondaries even. So all the data protection tasks can happen on either side or any of those if you have as many as you want to. So full support of AGs, no support for the FCI. Let's go back into here. So I like the thing I talk about too is just, I can go in and look at the per file database stuff too. So I can actually see my data file, my log files, and actually look at latency problems with this. Because what happens is there's no easy way to troubleshoot database storage problems. And if you're all storage people, you've all probably had what we call the meeting where we all get around and we've had a consistent performance problem. The DBA has been complaining. It gets escalated. Now we have to have the storage admin, the network admin, a couple other admins, application admins, and the DBA sitting in a room trying to figure out where the root cause of this is.
Shawn, can you get the metrics on a per file basis as well?
Yes. So this is the MDF, this is the LDF. So this is the data file, this is the log file. So I can break it down and actually get my metrics for that.
So the metrics, the charts and all that stuff on a file basis.
Oh, the charts wise. So yeah, I'll make you. So it's on a different screen, unfortunately, which is not the most intuitive. Whoops. So let's go pick. Where's my 880 at? There we go. And then managed objects. And let's go pick a database. And so I don't get the per database so I still get the files wise here, but I don't get the charts for per file. I get the real time stuff per file. And then we can, in the analytics, we can pull more granular stuff, but not through here, all your cloud-based stuff, but not in the system here.
The per files are still available in our sort of legacy VMstore UI. It's Flash-based, and that functionality hasn't been ported over to HTML5 for parity yet. But Using the old UI, that data is still historically available for the 1 week on a per file level, but we're waiting on an upcoming release to get that also brought over into TGC.
Can I just check, guys, as well? Is this can I see this information if I physical SQL hosts, Lord forgive us, physical hosts for anything, but physical SQL hosts, and I'm just presenting these database, as SMB shares straight to those servers? Will I still see the same info, or does this have to be inside of a VM?
No, and we're not cracking the VM at all. So if it's a physical box, which of course I'm looking at this physical box here, and I don't have any databases on it right now. We just did a data center move and we cleaned a bunch of things up and we haven't rebuilt certain things. So our physical box, if I go put some databases on here, yes, they'll show up in here just the same way as they would show up on this is a virtual machine. We actually are talking to SQL Server. We could care less of how you're hosting SQL Server. Again, except I don't support Linux. So as long as your SQL Server is on a Windows box, it doesn't really matter.
So can I just check one other thing as well? Because I wasn't particularly clear about this when we looked at the VM data stores earlier on. Can you pull any information from the infrastructure as well? So you pulling anything from SQL Server to help inform the analytics and the information you present here?
We're pulling a little bit of data, but not a whole lot. Mostly from the standpoint of we connect to SQL Server, we pull basically out. Obviously, we're pulling the database name because we're gonna figure it from somewhere, and we're pulling basically the location of it's at, and then also if you drop and create a new database, we pull that from SQL Server to make sure that's how we find it, kind of stuff. Because if I actually don't register the SQL Server, I can still put the database on this SMB share. However, you'd get none of the goodness of our auto QoS process, and we're lacking a lot of the insight and visibility because you won't see them listed here. So obviously, you have to register the SQL Server so we can see the information.
So Shawn, this is a good point a good question by Paul, because maybe we'll take a step back, right? So there are two integration points, right? One is actually placing the data on the system, right? So that's through the SMB or NFS share. And the other one is the metadata type of interaction with the APIs. And that's true for the virtualized workloads, for the databases, for the containers. So when the VM store speaks with vCenter, it learns about the VMs, their files, and that's how we map those into the file system elements. Same goes for databases. So
yeah, just to follow up too on Paul's question regarding that. So as of now, so your algorithms, your Monte Carlo based algorithms, stuff that you've got are not currently digging into doing the database level analysis at this point. Is that correct?
So I guess we need to clarify what those two levels. So Monte Carlo is used for the storage pools capabilities, right? So when you group multiple appliances and then the system decides where to place workloads across those various appliances in the pool. So that uses Monte Carlo to predict. And that is available for virtual machines. That's not available for databases.
Okay.
And mostly because you can't vMotion a database yet. There's not a process. I have talked to Microsoft engineering about it. They want to be able to do that because right now, if say you're in Azure and you want to go from a medium to a large database instance, you actually have to backup restore and migrate your database because they can't move it for you easily either. Right. Eventually, SQL Server will support the concept, but not today.
Right, so that's why we can't offer that same functionality, for databases, but we do offer all the rest for databases. So all the appliance level capabilities, the automatic quality of service between databases and VMs, database and VMs, container volumes, quality of service, snapshots, everything is available there.
Yeah, because if I go into the performance reserves, what you see the changes. Some are going to be VMs, some are going to be databases. This is a data. So these are. All right, this is a VM. This is a VM. This is a VM. The rest are databases. So obviously our reserve changes, as Rob was talking about, how we're allocating system reserves. You're actually done per database or per VM. It's all mixed into one large hopper in determining how we allocate the processes. So that way, when that one DBA writes a bad query, or actually usually it's a business analyst writes a bad query for reporting, and some database that sits on a VM or sits on a DBA database server that doesn't do much most of the time now is running some massive multiple gigabyte report that's going to churn through I/O for hours and hours. Guess what happens? On that SQL Server today, all of the databases sit and share one database pool or storage pool. All other databases in that server will now be slowed down and impacted by that one query. And if it's a VM and it's on a data store with, say, 6 other SQL Server VMs, all VMs are going to be impacted by that one bad query. With this, since it's auto QS process, each individual database has its own process. Only that one database with the bad running query is going to be governed. The rest are still going to get the same amount of performance reserves as they had in the past, which allows all your other applications not to have issues anymore, which is actually going to lower your help desk calls, because now it's only one database impacted, not many databases impacted when something bizarre goes on in the database world.
And you'll know exactly which one, right, Shawn?
Exactly. And we can spot that in seconds. I mean, the fact that we could find out things that used to take me hours, when I was a DBA, through a bunch of queries and third-party tools to go track stuff out, I can go look inside of VMs, inside the TGC. I can click through, and basically in usually 15 minutes, I can tell you, pinpoint where your performance problem is at from a storage perspective. I can also isolate, is it actually, in databases, we tend to have logical hotspots and the physical hotspots. The logical hotspots tend to be actually memory mapping and latching contention issues, which the problem is they show up to the DBA as a storage related thing because it's an IO call. The problem if the memory is stored in if the storage block it wants it's in memory, it still has to lock and latch it there to do work with it. And so now the DBAs usually don't understand what the logical one versus the physical one, and the numbers for tracking that are very difficult. So to the DBA, it's a storage issue, even though storage is perfectly fine. We can isolate and show that it is definitely a logical hotspot inside your memory, basically from a database architecture perspective, not a storage performance problem. I can do that in seconds as well. The next biggest thing, again, I could talk for hours on this. I'm just going to show you basically how we're going to change the world from a DevOps / CI/CD perspective, our database cloning processes. So we do all kinds of database protection things. Everything you can think of from a storage protection from, you've done your storage people, you've done snapshots. Now we can do those snapshots per database, and each of our snapshots are independent, and also there's not a chain. So in other words, I can go up and down my thing and do recovery from my snapshot chain anywhere and keep the rest of the chain. So if I happen to have 40 snapshots, I can restore number 20 and still have all 40 snapshots there. So I can restore number 25 or number 15 later on. It doesn't really matter. Also, our snapshots do not stun or impact my SQL Server at all. So in other words, you can run snapshots all day long, and a DBA will never be able to figure out how often I'm running my snaps. So what we're going to do real quick, though, is with this, I'm going to do a clone of the database. Let's go look at the database real quick. So here, down in databases, I have an AdventureWorks DW database. So AdventureWorks is a Microsoft test sample database.
So Shawn, I guess the question on this snapshots not stunning the database, is it an application? Is it consistent? I can't even think of the right word. Is it an application consistent snapshot, or is it crash consistent? I guess.
So there's crash consistent and there's application consistent. So an application consistent requires a VSS snap, which will introduce your IO pause.
Right.
We're doing crash consistent.
I got you. Okay.
Which basically is the same type of process is if I have an AG or an FCI failover, either manual or basically an automatic process, if something crashes and it fails over, or if I trigger a failover, they also do a crash consistent failover process. So crash consistent is not a scary thing. And the other thing is our crash consistent, since we own the file system, we are actually managing it per database file. We actually know where your writes are going. So we're doing the right leveling process as our ingest of the IOs, meaning I don't need to do a VSS quiesce. See, other storage vendors, because they're writing to a block in a LUN, they don't know where that IO or which database that IO is part of. So they have to stop all of SQL Server to make sure all the writes to the logs from the buffers are cleared properly. So they have to stun the system, slow it down, which causes what we call the caterpillar effect. Just like on the interstate, when one person up ahead stops on their car or slows down a lot, The car behind slows down more and more and more, and then a quarter mile up the road, everything actually comes to a complete stop on the interstate. Same thing happens in databases. When I do a VSS snap, it stuns the system. All the requests or transactions just start crashing into it and pausing, even though they're only stunned for say 3 seconds at the source. It may take 2 or 3 minutes before all those backed up transactions clear out of my buffers and I'm back to normal performance. So if I'm doing a snap every 15 minutes and I introduce 3 minutes of slowness, not a tenable solution. This, no impact.
Okay, thanks.
Sure. All right. So here, 322 gigabyte database. So this is a Microsoft sample database. I've blown it up with a bunch of extra data. I've randomized a lot of things that have a lot of just junk in here just for size. And on this is my production database. My dev server, which is here. I have an AdventureWorks database already over here, but I don't have a field day database. I've got some GUI databases, blah, blah, but no field day database. And we're going to create a clone of that. Before I do that, I'm actually running my dev properly, meaning my prod and my dev systems cannot see each other. If I ping between my prod system and my dev server, I'm on my past dev now because I run Management Studio, never on the SQL Server. I'm a truest DBA kind of person. So these two systems can't see each other. So normally how I get data refreshing from system A to system B is I back up to my whatever point I have my normal backups, and then I have to copy it through my jump box from network A to network B because I have isolation, and then do a restore process. Very slow, very clunky. So into TGC databases tab. I prefer to go to the SQL servers from here because I have an AdventureWorks database on every one of my SQL servers. So I have multiple copies. So I go find my past prod database server, DW, right click, we're going to click clone. It's going to do a new snapshot. We're going to change the name of the clone to field day. If I can type, never type in a demo.
Are the snaps read-writable or just readable?
Just readable. I can mount them and make them rewritable, but then I create a new chain.
Okay, thanks.
So I have a new process. And so for here, we're going to take a brand new snapshot, even though I already have some existing ones. And then I got to specify where I want it to go. So in this case, I'm just going to go put it to a different data store or a different basic SMB path. Also, because I do security properly, because I want to think security minded, because databases need a different level of security than most other things, especially when they have credit card numbers and that kind of stuff stashed. My prod database servers cannot see the storage path to my dev database servers from a network perspective.
You can create a snapshot to a different SMB share.
So it's the same appliance, but it's a different SMB share.
Okay. All right. Gotcha.
So I'm not going to a different appliance. But at the end of the day, the SMB share is just a logical folder pathing we have on our file system. So yes, it's a definite SMB share level.
Got it. Thanks.
And so that means I can control my security now. So database server A cannot see this share, even though I'm going to clone to it. And it takes between 5 and 10 seconds. There it goes. So now databases refresh, and you see I've got a field day. Did I not pick the right server? I picked the wrong server, didn't I? I created it in the wrong place. So my bad. That's all, again, why we don't do. This is why I usually tell you to record these things. I did record it, but I'm going to do it live because it's more fun. Okay. So field day clone. I use the word clone in there because I have scripts that automatically delete all my databases named clone after a while, just because I do so many demos. I automatically clean things up. New snapshot. What I didn't do is specify the server. The cool thing is I have lots of servers here. They're not in a great order, so sometimes it's hard to find them all. And this is actually keyed properly, so I can just start typing in dev, because I'm looking for dev servers, and it filters down my list to just my dev server. So I pick the dev server, and then I have to go pick the right SMB share path. My bad. Why did my snapshot get clicked? New snapshot. Past dev, Okay. Now it's all correct. Go back to the same 10 seconds. All right, fine. Now it's faster. Got warmed up.
So not only a different SMB share, but a different SQL server?
Correct.
Yes.
So now you see I've got a field day clone here on this past dev server that can't see each other. It's a full copy of this database. It has its own IO path now. It can run its own way. I can do these clones via REST API, PowerShell toolkit, or through the UI like I just did. We also integrate with any CD, CI, or DevOps tools because, so say if you're doing QA testing and you're doing bad data testing for QA, so you're doing bad injection information. The problem is some things get successful and then I get these ugly data points in my database, which causes the next test to actually run slower. I can refresh that database that fast. Every time I refresh my application server, I can refresh the database or refresh the database between every single test if I want to, because I can do it usually in under 10 seconds. So the refreshing process, I can crank it through. In fact, one of our customers is doing that. They're doing their QA process. They used to not refresh the database, but they refresh the app servers and other things on a regular basis with that. And then they would have, but the problem is, in the middle, they'd have to refresh the database manually because we call stat skews problems, which would cause performance issues because we put all kinds of bad data into the database over the QA process. Now every time they're doing a test, they're actually doing a brand new copy of the database, and now they can parallelize it. So they can have 20, 40, 100 copies of the same database. So their DevOps QA process goes in seconds. Now there's no reason with this to have a developer ever have to share a sandbox. Because most DBAs work on a small subset or developers work on a small subset of the data on their laptops. And then they write code that works great when I have 1,000 rows. It works horrifically when I have 100 million rows. And that's one of the differences. So now they can be testing or running their code nonstop in a sandbox that has a full copy of the data that can be refreshed on demand by them, not by some storage admin, when they want to, as fast as they want to, and as often as they want to. So anybody who's in a DevOps world, this revolutionizes how they think about storage. And the limitation actually from this is how the DBAs think, because the DBAs have been doing the same thing for 25 to 40 years. They don't think of changing things. They've probably tried storage snapshots sometime in the past and found they're either because they have a VSS requirement to make them consistent or to make them work properly, which they couldn't tolerate, or they had to isolate things down to individual volume. So like a vvol process, or individually, if you look at some of the other guides from other vendors, they tell you to put each individual database that's on its own data store or its own drive or own LUN to make this all work. Not functional. And then the same thing comes from database protection process. So say if someone corrupts my production database, I can bring a clone up and fix, one of my things I usually do is, this is about a 5-minute demo, and I don't think I really have the time for it. But basically what it does is I make a bad update and I mess up data in production. I just go into the latest snapshot, I mount it back up, and then I just go mine the data back out. It takes a few seconds to go write my query from a good DBA perspective to go clean that up. Today, I'm either mounting like a Veeam or a Cohesity backup, or I'm using some other third-party tool, or having to do a full restore from something else to go do this. A Veeam and Cohesity can bring it up online really fast, and other third-party tools. However, the performance on those is really bad. So if I have to go fix 1 million rows, it's going to take a long, long time. Versus here, I can bring it online, full performant database access within seconds. So now, and I tell people, you're going to spend more time deciding to use this technology to do your data recovery from a corruption issue, whatever problem, than you will actually do the actual fixing. The meeting with the managers to decide, let's go do this, will take longer.
Shawn, just to revisit, like all those bad behaviors, all those kind of nasty things that we see in DevOps, again, VMstore's QoS is ensuring that the production databases that our application sensitivities all care about, those are not impacted by those bad behaviors when those CI/CD or DevOps.
Exactly. So since I'm using shared storage, people worry about is, okay, now my developer has this thing, they're writing bad queries or big queries, is it going to impact production? And the answer is no, because of the QoS process is preventing that, guaranteeing those people to use that. Also, so you can do this is the clone. You can see my snapshot. It's only using 8 megabytes of space. So if this is a 330 gig database, only uses 8 gig on my clone. So I made lots of clones. Obviously, this is going to grow when I do queries and I do updates to schemas and this kind of stuff. But as I insert new data, this is going to change. But from a QA perspective, there's usually no data change or very minimal. From a development perspective, rarely you'll see more than 10% of the total space being utilized or being changed on that copy. So now I can, instead of having like the old, that's a couple of years ago, most people had Flash for production and had dev was on spinning disk. the amount of storage space you wasted because you didn't get universal dedupe and compression processes was actually more expensive than running all of it on a VM store. Because here I can have 12, 15 copies of a 2 terabyte database using, with dedupe compression, and all the Delta files we're talking about is still under, say, 600 gigabytes of space. Versus if I put anything on a spinning disk for dev stuff, that's still using 2 terabytes of spinning disk plus these 600 gig of my compressed paste.